All right, so as you can see here, I've erased the whiteboard, or light board as it's called, and put up a different ordinary truth table here. Just to be clear here, what we're looking at is one statement here, tilde A wedge B, then a slash to separate it from this other statement, A horseshoe tilde A, and then finally a slash to separate it from C as a single statement. And so as you can tell, then we're dealing with three different letters in this one, A, B, and C. And so remember then, the little formula here is 2 to the third. So in other words, 8 rows we would need to have. And so that's what I've went ahead and created here. And if you want to be writing this down, go ahead and pause the video to get all those T's and F's in there. But any 8-row truth table, or any truth table where you're having 3 different letters, will have this pool of values. Again, note here the pattern, as I explained before. The first half here, first 4 are true, second half false, and then we split that in half. So if we had 4 trues and then 4 falses, we'll have 2 trues, 2 falses, and then, rinse and repeat, as they say, until you fill it up. And then finally, if we had 2 trues and 2 falses, we get to the far right-hand column. That one will always end with true, false all the way down. So we've got our pool of values, we've got our statements here. So really all we need to do then to get started is identify the main operator columns in each of these. And so looking here, sometimes there is a little bit of a difficulty here. When there's a tilde off to the left, sort of lurking out there, do understand that when you have these parentheses here around the rest of the statement inside, the tilde then will actually be our main operator value, okay? So it's the tilde that's the main operator value. And if we want to sort of identify the order of operations, we can say that it's going to go like this, right? A and B will feed into the wedge, and then that will feed into the tilde, right? The tilde being the main operator. When we get to the next statement here, it's a simpler statement, and so hopefully it's fairly clear that it will be the horseshoe that's the main operator. Do understand then that when you have a tilde in front of a single letter, you want to do that tilde right away, because that is actually the value that will be feeding in to the horseshoe, right? So we're going to be dealing with a horseshoe, the tilde here. The tilde values are going to be feeding into that horseshoe. We'll see that play out here in just a minute. And then finally, of course, we have this very simple statement of just C. And so we still want to circle or identify that main operator column, even though it is just a single letter. But the good news is, here we are at the end, we will, in order to generate this, simply be able to copy over the column of information there from C. So in other words, we're looking at true, false, true, false, true, false, true, false, right? All the way down, just true, false. Okay, so we have that. And of course, we could identify, I won't write it on the screen here, but we could identify this, of course, as a contingent statement. Excuse me, just had to suppress a sneeze there. So we'll go from that to this one. And so we're going to copy over the A columns there. So we're looking at 4 trues, followed by 4 falses. Sorry about the squeaking sound, but anyway, 4 trues followed by 4 falses there as well. So when tildes are involved, you do want to be careful here. So remember that all of these trues and falses, the tilde then will flip those to the other values. So we're looking actually at false, 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 followed by true, 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 and true. Okay. And as we've already indicated here at the top, it's those values, the last ones we've just come up with here on the right-hand side, those are what are going to be feeding into the horseshoe. So follow with me here, but we're looking at true, horseshoe, false. False, right? That's the only way to make a horseshoe false. True, horseshoe, false. Well, we've heard that one before. True, horseshoe, false, right? We got that. True, horseshoe, false, right? It's getting a little old, but anyway, that's still false. Go to the 5th row here. We're looking at false, horseshoe, true. Well, false, horseshoe, true is going to be true no matter what. False, horseshoe, true is still true. False, horseshoe, true, true. And one more time, false, horseshoe, true gives us true. And so once again here, we can say, well, this statement here, A horseshoe tilde A, is definitely contingent. Sometimes it's true, sometimes it's false. And with that, we can come to the last statement here. So we'll copy over the A information, 4 trues, followed by 4 falses, right? It would be nice to have lines here on the screen, but I'll do my best. And then B is true, true, false, false, true, true, false, false. All right, just plugging those in from the pool of values. And I will just say here, squeezing my face into this little gap here, that sometimes there's a question as to what order to write these letters here in the pool of values. And of course, in the previous video and this one, I've written them in alphabetical order. But what I actually recommend is just write these letters in whatever order they appear in these statements. So it was A, then B, then finally C. That's the order I'd recommend writing them in. It tends to lead to less confusion when you're transferring over the information. So that's my tip. At any rate, back to this statement here. We're going to save the tilde column for last because that's the main operator. So we're looking at the wedge, and this is a great way to practice these operators, right? So we're looking at true, wedge, true, which is true. True, wedge, true is still true. True, wedge, false, right? Remember, anytime there's true feeding into the wedge, it's true. True, wedge, false, true. False, wedge, true is true. False, wedge, true is true. False, wedge, false, right? That's the only way to make the wedge false. And so that applies here at the in the 8th row as well. So what do we do with the tilde? We simply take all of the last thing we did inside these parentheses that the tilde applies to, the wedge column, take those values and flip them here with the tilde. So false, 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 false. And then we get down to the 5th row, and we're looking at true, true. Oh, I apologize. What am I saying? Getting ahead of myself. Those are not true. Probably already picked up on the fact that these videos are not being edited. I'm actually not sure how to edit them. But if I could edit this, of course, I would delete that mistake and make it appear as if I never make any mistakes. But nonetheless, we have true here becoming false, true becoming false. And now finally, in the last 2 rows, we have those 2 falses there becoming true, right? So just to reiterate, so there's no confusion, it is the wedge column that is feeding into the tilde. And so it's all of those values being flipped by the tilde to their opposite value. And so once again here, we can see quite clearly that we have this is, in fact, a contingent statement, right? And so having done that, we can also compare these statements here. So we have, comparing this one to this one, are they logically equivalent? Well, they're the same, the same, the same, the same, different. So they're not, logically equivalent. They're also not contradictory. So then we quickly come to the question, as we often do, to the question of whether or not they are consistent. In other words, can we find at least one row where both of these statements are true? And we do here in the 7th row, so they're both consistent. These are 2 consistent statements. We can pair up these 2. Are they logically equivalent? Different in the 1st row, so they're not logically equivalent, though they might have a shot at being contradictory, except that in the 2nd row they are the same, so they're not contradictory either. Mightn't they be consistent then? Are they both true in at least one row? We get down to the 5th row, it's true. 5th row, it's, let's see, 1, 2, 3, 4, 5, yes. They're both true in the 5th row. They are consistent as well. We can also ask the 1st and the 3rd statement. Are they logically equivalent, etc.? 1st row, they're different, so they're not logically equivalent. They could be contradictory. False, false, though, in the 2nd row, so they're not contradictory. Are they consistent? Well, again, here for the first claim, we have to go all the way down to the 7th row to see that it's true there. And what do you know? It is also true in the 7th row of this 3rd statement here. And so these 2 statements are consistent as well. And in fact, and you'll be doing something just like this on the exam, and in fact, we have true in the 7th row, true in the 7th row, and true in the 7th row. All 3 of these claims are consistent. They could all be true at the same time, in other words.